Odometry. We hear this word all the time when talking about robotics, and it's kind of a buzzword. But what exactly is it, and how can we use it for this year's season? Odometry is really useful and can be used to determine where your robot is on the field mid-match. Instead of saying drive forward 20 inches, odometry allows you to say drive to this position, and it will go there. It works with a known wheel diameter and this thing called a rotation sensor. It works by keeping track of what degree a wheel has been turned to. Knowing which degree the wheel is at allows us to calculate how much the wheel has turned, and then we can then calculate the distance the robot has moved. I was prototyping a design for the RECF Pinnacle game that uses a 3D printed odon pods, but now my school switched over to Vex override, so now I can't use any of this, but I'll share with you the design process because it can be pretty informative on how to design your own for any game you want to do. I first printed a spring out of PLA to test the flexibility of these springs and to see how I can use it in one of my designs. These springs bent in every direction, which turned out to be a problem. I then printed this wood cut 3D print to see if it would be flexible and it would bend or even be springy, but I printed it too thick and it didn't bend at all. Printing it thinner allowed it to bend, but it did not spring back, which made this thing useless. My initial thought was to design a leaf spring because many people use those on their bots and they're really good at keeping touch with the floor, which is really important for making sure there's no air in your system. I used the original spring design but added a pivot point on this one, but it would still flex in multiple directions, which was a problem. This design tried to get rid of the side-to-side flex while maintaining the curl, but it still was, the walls were just not strong enough and it still allowed it to bend side to side. I then tried to add rails, but it would still bend out of it and it still slipped off the rails and it wasn't strong enough. So then I removed the rails and made the walls thicker so it would no longer bend side to side. Leaf springs have an ever so slight error though, because they pivot at a point and they don't move directly vertical, so the distance from the robot changes ever so slightly. So then I revisited the idea of using rails, but these rails bent too much and they didn't actually work. I switched to a full rail design and that removed all the unnecessary bending in the design. I added another loop to the spring so the spring could compress further, and then I added all the electronics and found out that the rotation sensor bends a little off the axis a little bit. I fixed that by adding another loop over the rotation sensor to keep it locked in place. Then I also drilled a hole in so you could easily screw in one of the screws into the rotation sensor. And this is the finished design, yeah. This has no use to me anymore, but if you guys are in the Pinnacle game, then I'll make sure to leave the file in the description for you. Assembling it's pretty easy, so this is what it looks like. Hey, if you guys found this video useful, please make sure to leave a like and subscribe, and good luck with this season with your robot.